All right, let's dive right into today's explainer and explore this fascinating, massive engine sitting at the very bottom of our globe, the Southern Ocean. Now, we usually think of oceans as just these big bodies of water separating the continents, right? But the Southern Ocean is completely different. It's this incredibly dynamic, hyperactive system that fundamentally dictates the climate, the currents, and the biological health of our entire planet. To really wrap your head around the sheer scale of this ocean, just consider this number for a second. 170 million. That is 170 million cubic meters of water flowing through the Southern Ocean every single second. It is a volume so massive, it's honestly a bit hard to fathom. It's driven eastward around Antarctica in these multiple roaring filamented jets. This constant flow is quite literally the heartbeat of the global ocean system.
The ocean without borders, an earthly anomaly.
So, when we compare it to our other oceans, which are essentially giant bathtubs trapped by land, the Southern Ocean is basically a boundless planetary roundabout. Think about the Pacific, the Atlantic, or the Indian Ocean. Their currents are entirely dictated by the fact that they eventually slam into a massive continental landmass, right? The water has to turn. But the Southern Ocean, especially down around the latitudes of the Drake Passage, has zero north-south land boundaries. It completely and uninterruptedly encircles the Antarctic continent.
And this unbroken geography creates what's known as the Antarctic Circumpolar Current, or the ACC. It's a relentless eastward flow that acts like a massive, unstoppable racetrack without walls. Because there's absolutely no land to block it, the ACC is actually the ocean's closest analog to major atmospheric wind systems, like the westerlies. It just keeps flowing, driven by the winds, creating this immense ring of moving water that completely isolates the Antarctic region from the northern oceans.
Section 2. Earth's Ultimate Mixing Bowl, Connecting the Global Oceans.
Because the ACC connects the three major ocean basins and reaches incredibly deep, it's the primary vehicle for water flowing between all the oceans. Basically, the Southern Ocean acts as the ultimate global mixing bowl. It pulls in these unique deep water masses from the Atlantic, Pacific, and Indian Oceans, and then all those waters mingle and upwell along steeply tilted density surfaces. Then, intense sea ice formation near the continent rejects freezing brine, which creates this incredibly dense, freezing cold Antarctic bottom water. These transformed waters, some heavier, some lighter, are then shot right back out northward to fill up the deep basins of the rest of the world.
Moving to Section 3, the global climate break, sequestering heat and carbon.
Here is a totally wild stat. 60%, a staggering 60% of the globe's uptake of excess heat is absorbed right here in the southern hemisphere. As our global atmosphere warms up due to rising greenhouse gases, the ocean steps in as this massive delayed response system. Without the Southern Ocean actively pulling this immense amount of heat down into its deep and abyssal waters, the surface temperatures across our entire planet would be radically and dangerously higher than they are today.
And it's not just heat, it's a phenomenal carbon sponge too. The Southern Ocean alone is swallowing up roughly 31% of the world's anthropogenic or human-caused carbon dioxide emissions. As the surface waters cool and sink, forming what researchers call mode and intermediate waters, they literally drag that human-produced carbon deep underwater, effectively locking it away from the atmosphere.
By pulling all this heat and carbon out of the sky, the Southern Ocean acts as a massive brake on global warming. The source material actually calls this a climate service, and honestly, that hits the nail on the head. It's an essential planetary function that we literally depend on to soften the blow of modern climate change. We are buying time here, and the currency is the Southern Ocean's capacity to absorb our excess waste.
Section 4. Diatoms, krill, and survival, the biological engine.
Now, let's zoom in a bit because the life here is incredibly unique. Since the physical processes like wind and ice retreat are so extreme, the plankton have to respond fast. The phytoplankton down in the Antarctic, specifically the diatoms, are unusually large compared to the ones you'd find in warmer tropical waters. And because they're so large, they don't require this long, complicated food chain for their energy to be consumed. This makes the transfer of organic matter directly to higher trophic levels remarkably fast and efficient.
What this creates is a highly efficient, essentially four-step food web. So the large diatoms capture the sun's energy. They are then eaten by copepods, which are in turn consumed by Antarctic krill. Now these krill act as the crucial anchor for the entire ecosystem. Thanks to this incredibly streamlined energy transfer, those krill can directly sustain almost all the higher predators in the ocean. We're talking everything from specialized fishes all the way up to leopard seals and those enormous baleen whales.
It's this beautifully balanced, highly efficient system. But we have to ask ourselves, what happens when this perfectly tuned planetary engine is pushed past its limits? What exactly happens when the biological engine and the physical currents collide head-on with rapid warming?
Which brings us to Section 5, a system under threat, the boiling point.
The data paints a pretty concerning picture right now. As the global atmosphere warms, the Southern Ocean's deep and abyssal waters are showing distinct warming trends of their own. This heating messes with surface wind speeds, which actually threatens to reduce the efficiency of that vital CO2 sink we just talked about. On top of that, physically speaking, warmer water simply holds less dissolved gas, meaning oxygen solubility is dropping. And critically, these rising temperatures are actively disrupting the life cycle of the Antarctic krill, the exact creature that anchors the entire food web.
To see just how devastating this physical squeeze could be, take a look at the unique, specialized marine life down there, like the Antarctic icefish. These remarkable fish, part of the Chanocthidia family, completely lack hemoglobin in their blood. They've survived for millions of years purely because those freezing Antarctic waters hold so much dissolved oxygen. But with warming temperatures and reduced oxygen availability, those waters could very soon become completely unlivable for them.
There's a great quote from researchers Stark and Morrison that really sums it up. They point out that we just cannot separate the fate of the Southern Ocean from the fate of our global climate. It has shaped our planetary past, it regulates our present by shielding us from the full force of our carbon emissions, and its evolving health is unequivocally going to dictate our future.
So I'll leave you with this final thought to take away from our explainer today. We've seen how this unbounded ocean acts as a massive mixer, a planetary climate break, and a totally unique biological engine. But if the waters warm to the point where the krill collapse, and the currents shift so they stop absorbing our excess heat and carbon, are we truly prepared for the world that follows? Thanks for exploring this fascinating planetary engine with me today.